Okay, for this sample problem number 4, the beam shown is made from two boards. Determine the maximum shear stress in the glue necessary to hold the boards together along the seam where they are joined. This problem asks us to determine the maximum horizontal shear stress in the glue joining the flange po and the web of a built-up wooden beam. So, ito yung glue line kung saan idudugtong niya yung dalawang wooden boards. So, the governing equation, so remember VQ over IB, where FB is the maximum shearing stress in the glue. V is the maximum internal shear force, where we can obtain it from the given loading po. Q is the first moment of area of the portion above the glue line. So, basically, ito po yung Q kasi siya yung above na area dito sa glue line. Then, I is the moment of inertia of the entire built-up section. B is the width of the glue joint. Basically, that is the web thickness equals to 30 mm. Okay, the first step is to determine the maximum shear force. We have the simply supported beam na may span po na 8 meters. A uniformly distributed load of 6.5 kilonewton per meter acts over the right 4 meters. So, we have to replace the distributed load with its resultant. So, 6.5 times its length for, so it is equivalent to 26 kilonewton. So, this resultant acts at the center of the loaded portion po. Since the load occupies 4 meters, so its centroid is equal to 2 meters. Then, we take a moment at point A to determine first the reaction at point B. So, yung unknown reaction at point B times the lever arm na 8 meters papuntang point A minus yung resultant ng uniform load natin, 26 kilonewton times the lever arm. So, it will act at the center of the loaded portion. So, 2 meters plus 4 meters. So, yung lever arm niya po equals to 6. Equal to 0. So, yung makukuha natin na reaction at point B is equal to 19.5. Then, getting the summation forces vertical equal to 0. So, RA plus 9.5, then minus 26 equal to 0. We get the result equals to 6.5 kilonewton. So, by observation, the largest internal shear force po occurs at the left support. So, ito na yung i-consider natin na V equals to 19,500 Newton. So, i-convert na natin to 2 Newton, kaya yan yung naging sagot. Kasi ito, naka-kilo Newton po yan. Okay? Okay. Next. So, second step natin is to locate the neutral axis. So, divide the section into two rectangles. Yung flange po, the area 1, it has a dimension of 150 by 30. So, yung area 1 is equal to 4,500. Then, the centroid from the bottom po is equal to 150, then yung kalahati ng 150, then yung kalahati po ng 30, 15 plus 150 equals to 165. So, from the bottom po yung centroid ng area 1. Then, for the area 2, so yan yung web. Yung dimension natin is 30 by 150. So, equal to 4,500 mm squared naman po yung area 2. Then, yung centroid naman, so kalahati lang ng 150, so 75. So, to get the total area, so get the summation of the two areas. So, we get 9,000 mm squared. Then, using A area total times y prime equals the summation area times y. So, 9,000 times y bar is equal to 4,500 times 165 plus 4,500 times 75. Therefore, the neutral axis is located 120 meters above the bottom. So, ito po yung location ng neutral axis. Okay, for step 3, we need to compute the moment of inertia using this formula. So, the moment of inertia of the entire section is equal to the summation I plus AD squared. So, the first rectangle, so yung base niya is 150 times yung height niya is 30 cube over 12. Then, yung formula niya, kailangan natin kasi i-transfer yung centroid niya papunta dun sa neutral axis ng entire section. Kaya, kailangan tong i-add. So, AD squared. So, yung area 1 is 4,500. Then, yung centroid distance nito papunta sa neutral axis. May nakompute tayo na y1 na 165 minus yung y bar. So, yung matitira po dyan is yung d squared or d, yung distance niya. So, 165 minus yung y bar. So, yung matitirang gap is yung d. Then, squared lang natin. Then, for the second rectangle, yung base niya po is 30 times the height na 150 cube over 12. Then, again, we need to transfer the axis, yung centroid nitong area 2 papunta sa neutral axis. Kaya, magdadagdag ka ng AD squared. So, 4,500 yung area 2 times yung distance ng centroid ng area 2 papunta dun sa neutral axis. So, kung meron tayong distance ng area 2 from the bottom na 75, subtract lang natin siya sa 120. Yung matitira is yung D dito. So, yan yung naging computation. Then, squared natin. So, using your calculator, we get the result equals to 27 times 10 raised to 6 mm raised to 4. Okay. To compute the first moment of area or Q, so ito. The glue joint is located po between the flange and the web. So, the area above the glue line, ito yung glue line, is only the top flange po. So, makukuha nating area. So, based dun sa formula ng Q, so area above dun sa point of interest. So, 150 times 30. So, ito na yun. Then, times yung y po, meaning that is the centroid distance, the distance from its centroid to the neutral axis. So, diba yung A1 natin from the previous computation, ito yung distance niya from the bottom po. Then, ito yung centroid niya. Then, minus lang natin yung location ng neutral axis from the bottom po. Yung matitira is yung distance na to. Kaya, ang lumabas is 45. So, 165 minus 120 is equal to 45 para makuha yung distance ng centroid to neutral axis. So, yun na compute natin is 202,500 mm cube. Then, to compute the shear stress, so, just plug in all the variables. So, yung V natin, so, 19.5 times natin sa 1,000 para maging Newton. Then, yung Q is 202,500. Yung I natin is 27 times 10 raised to 6. Then, yung width natin or base is the thickness ng web po na 30. So, yung nakuha nating sagot is 4.875 MPa. So, ano yung ibig sabihin nito? So, lumabas na yung maximum glue shear stress na 4.875 MPa ay yung dapat na kayanin ng adhesive para hindi sila maghiwalay o hindi maghiwalay yung dalawang kahoy. Okay, for sample problem number 5, a plywood beam is built up of 1/4 inch strips separated by blocks as shown. What shearing force V will cause a maximum shearing stress of 200 psi. So, in this problem, the allowable shearing stress is given to 200 psi, and we are asked to determine the corresponding shear force V. So we will again use the horizontal shearing stress VQ over IB. Since the shearing stress is known po, we solve the equation for V. Ito yung pinapahanap. Okay, so the given are the shearing stress, the overall height, 12 inches, and the thickness of plywood strip. So, ito yung tinutukoy dyan na 1/4 inch strip. So, kinonvert na natin siya to decimal. So, 0.25. So, tatlong 1/4 inch na strips. Okay? Then, that is the thickness no strips. Then, yung top and bottom spacer na block. So, ito yung spacer na may dimension na 2 by 1 inch po. Then, the section is symmetrical. So, the neutral axis is located at the center. So, Y bar is equal to 6 inches. So, to compute the moment of inertia, so treat this section as the outer rectangle minus the two interior openings. So, the outer rectangle po has an overall width. So, i-add nyo lang tong mga dimension. So, yung overall width natin is 4.75 and the height is 12 inches. So, the moment of inertia for the outer rectangle, so yung base niya is 4.75 times yung height 12 cube over 12 minus yung inner openings natin. So, yung width niya is 2 plus 2. So, yung total width is 4 po. Then, yung height naman niya is 10. Basically, yung 12 na overall height minus yung dalawang 1 inch po. Ang matitira dun sa opening na height is 10 inches cube over 12. So, the total moment of inertia of the built-up section is 350.667 inches raised to 4. Okay, to compute the first moment of area, since the maximum shearing stress occurs at the neutral axis, so compute Q using this portion. So, lahat ng area above the neutral axis, so yan yung kailangan natin na Q. Okay, considering this area po, so meron siyang, nasa na yun? So, ito na muna. So, considering this area, since ito symmetrical lang yung dalawa, so kunin natin muna itong dimension niya. So, 2 by 1. So, yan yung area niya. Then, yung centroid nitong area, di ba meron siyang height na 6 inches. Then, minus natin yung kalahati ng 1 inch para makuha yung centroid, which is 0.5. So, yung matitira is 5.5. So, yan yung centroid nito. Then, since dalawa yan, so, imamultiply pa natin siya sa 2. Kasi dalawa yung area na yan. Then, for other area po, nung area above the neutral axis, ito. So, itong mga symmetrical sila. So, magkakamukha sila. So, kahit ito lang muna ang i-consider na dimension na may height na 6 by 0.25. So, ito yung area niya times yung y. So, centroid ng area na to. So, kalahati ng 6. So, 3. Then, may tatlo tayong area. So, kaya i-multiply pa natin sa 3. Since magkakamukha lang sila. So, the total Q po is 35.5 inches cube. Next. So, substituting all the given values and variables po. So, yung V natin is unknown. Yung FB is given po 200. Yung Q na compute natin 35.5. Yung total moment of inertia 350.667. Then yung base naman at the neutral axis, ito yung tinutukoy. So isam mo lang yung mga thickness na yan. So 0.25 times 3. So tatlo yan na thickness dun sa neutral axis. Kaya nag-equate siya sa 0.75. Then use your calculator. Yung lalabas na sagot is 1,481.691 pounds. So ito na yung final answer natin.